Continuing lesson 7.3, if we look at page 398, number 5, applying the Pythagorean theorem here. So a box shaped like a right rectangular prism measures 5 centimeters by 3 centimeters by 2 centimeters. What is the length of the interior diagonal of the prism to the nearest hundredth? So first of all, we can draw a right rectangular prism. You may not have a whole lot of practice about this, so the easiest way to draw a right rectangular prism is to draw a square and then draw another square that's just intersecting it at the corner. Almost looks like the right angle symbol there. And then if you connect your corners, connect your top left corners, top right corners, bottom right corners, bottom left corners, you'll have a right rectangular prism, okay? It'll look a little bit off maybe because technically some of these sides you can't see from your perspective, so you could try to go in there and make some dotted lines out of those. Make it look more official if you want. So anyway, we've got 5 centimeters, 3 centimeters, and 2 centimeters. And they didn't really tell us, which one was the height and which one was the width or length. It doesn't really matter. However you put your numbers, you're going to end up coming out with the same answer if you do this correctly. So, like we talked about at the beginning of the lesson, the interior diagonal here, diagonal is going to go from the top face to the bottom face diagonally. So in order to figure that out right now, if we think of this red triangle, right now in that red triangle, we actually only know one side. We only know the 2 centimeters. So in order to use the Pythagorean theorem, we have to know 2 out of the 3 sides. What we can do, I'm just going to color code this to make it easier to follow maybe. We can find this blue line by the fact that this is a right triangle, this blue triangle, on the bottom face. So we start with our Pythagorean theorem formula, a squared plus b squared equals c squared. So on the blue triangle, we do not know what the hypotenuse is. So that's what we're trying to find. So the 3 and the 5, or the 5 and the 3, are the a and the b. So to maybe help make this easier to see, this is the triangle we're looking at. This is on the bottom. This is on the bottom face, the bottom part of our rectangular prism. Okay, and this is what we're doing right now. We're trying to find the diagonal across the bottom of our rectangular prism. So at this point, we're going to go ahead and square these. So 3 squared, 3 times 3 is 9. 5 times 5 is 25. And then if you add those together, is 34. That's c squared. We want to figure out what c is. So to get rid of the square, we need to take the square root. Again, when you take the square root, technically we should put plus or minus there, even though in this case the negative is not going to work because we can't have a negative length. Square root of 34, we could work that on the calculator just to get an idea of what it is. Okay, so I know square root of 36 is 6. So square root of 34 is just going to be a little bit less than 6. So maybe like 5.8 something?
Yeah, 5.803.
Okay. So other than that, I'm basically just making sure, is that the longest side in my triangle? It should be. If it's not, then I made a mistake. So 5.8 something's bigger than 3 and 5, right? Okay, so we're in good shape. So I'm just going to leave that as square root of 34. I'm going to leave it as square root of 34 because that's going to make my job easier now. And so now I'm just going to draw out again for you our red triangle now, so you can kind of visualize this a little bit easier maybe. So we had the 2 centimeters. The diagonal at the bottom, what we just figured out, is the square root of 34. And then now we're trying to figure out what that diagonal is. I guess just to avoid confusion, I'm going to use a D for diagonal or something like that. Because we just used C on the other part. If I use C again, you might get confused over what it is that we're actually looking at. So if we take this now and just substitute in, again, I'm just going to put a D there instead of the C just to avoid confusion between what we did on the first part and now. Substitute in for our A and B. So the 2 squared, 2 times 2 is 4. Square root of 34 squared, a nice thing there is the square root and the squared cancel out. So that's just 34. And then we add those together is 38. Take the square root. Technically we put plus or minus, although as always our distance can't be negative. So the exact answer would be the square root of 38. Square root of 38, if I told you something's square root of 38 long, that probably has no meaning to you whatsoever. And also the directions here said round to the nearest hundredth. So if you work that out and round that off to the nearest hundredth, then that is about 6 1600ths centimeters, 6.16 centimeters. And again, that is the longest side in that triangle. It's the longest diagonal that we could make, kind of like, you know, our umbrella problem. That's the biggest umbrella that could fit in this box, would be at that diagonal. And going back to our original rectangular prism that we drew, just understand too, these numbers, like I said, since they didn't say, you know, this is our length or width or height, you know, this could be turned different ways. And so you might have started, instead of 3 and 5 on your base, you might have started with the 2 and 3 as your base and figured out what's the diagonal of that. And your problem initially would look different, but in the end, you would get the same answer. Okay? In that case, you would have square root of 13 would be that diagonal. And you might say, well, square root of 13, how can that possibly work? Well, the other number would be different than for the other part. You'd have square root of 13, and you'd have a 5, and then you'd get 13 plus 25, which would be 38, and you do square root of 38 there as well. Okay, so even though initially your numbers, if you have it turned, the box turned a different way, you know, even if I take a box and turn it a different way, the diagonal from one corner to another corner is still going to be the same measurement. So we look at workbook page 94, number 5. Lee needs to find the height of the rectangular prism X. He knows D equals 15 millimeters. If he also knows the measure of line A, can he find the measure of X? So probably what I would do on a problem like this is just substitute in here. You know, instead of a D, I know that's 15. And A, it says we also know the measure of line A. Well, They didn't tell us what it is. Let's just say it's 2. I don't know. We know a number there, in other words, okay? The question is, can we figure out what x is? Well, if you look at this, to figure out what x is, on that triangle, how many sides do I know? I only know the 15. I only know 1. Okay, this is 15, this is x, and this is c. I only know one side there. Okay, we can go back and try to get the base triangle to bail us out here. But on that base triangle, I also only know one side. So if I only know one side, I can't use Pythagorean theorem to figure out another side. I need 2 out of the 3 in order to figure out what that is. Okay, so for this problem, we would have to say no. He only knows one length from each triangle, and he needs at least 2 lengths from a triangle to find another length. If we look at number 6, Sasha is building a treehouse. The walls are 6.5 feet tall. She is using a brace to hold up the wall while she nails it to the floor. The brace is 8 feet long, and she has positioned it 5 feet from the wall. Does her wall meet the floor at a right angle, and explain? So basically, what we're dealing with here, it just kind of boils down to something like this. So we've got the wall is 6.5 feet tall. The brace is at a diagonal here, trying to hold this up, and that's 8 feet. And then it's 5 feet from the wall. So you can see my picture's not to scale because the 5 looks bigger than the 6.5, but I'm not going to be concerned about that. I'm just making sure my numbers are in the right spots here. So the question mark is whether this is a right angle or not. Do we have a right triangle? And as we've been doing, we know we can use Pythagorean theorem to test whether this is the right triangle or not. Okay? The brace like that, by the way, that's a way that they can use to help support this until they get all the other pieces put together for their room or whatever they're building here. Treehouse, right. So on this problem, our potential hypotenuse, remember we can take our right angle symbol here, and that will point towards our potential hypotenuse. 8 is our potential hypotenuse. It's the biggest side in our triangle. And so this is what we're testing. So we work this out. 5 squared is 25. 6 squared is 42.25. 8 squared is 64. So the question is whether these two are going to add up to 64. Well, I only see a 0.25 as a decimal. There's no way that's going to add up to a whole number. You can add it up and it's going to be good. So 67.25 is not equal to 64. So no, this is not a right angle. Okay, so in other words, it might be good enough for supporting this for right now, but we'll have to adjust it later. Somehow we don't have quite a 90-degree angle there that we'll need to adjust that before we actually put that in place for our wall. Otherwise our wall is going to be leaning in or out. Number 8 asks which measurements are the dimensions of the prism to the nearest whole number. So dimensions of the prism, that's our length, width, and height. Well, they already told us 2 of them. We already know the 5 and the 8. Unfortunately, that does not eliminate any answer choices because 5 and 8 are in all of these answer choices. And this says to the nearest whole number, so that's my, might be thinking then it's not going to be coming out evenly. So the question is basically how tall is this prism. So that's our goal, is to figure that out. And this is a little bit backwards from some of them that we've done, because we actually, in this case, know that 13 meters diagonal, which has been what we've been trying to find on some of the other problems. One thing on this problem, we're going to make an assumption here, is that this actually is a right rectangular prism, and that we actually have right angles here. They should probably be telling us that, but anyway, that's the only way we could possibly figure this problem out. So if you'll notice, right now, if I try to look at this triangle to figure out the height, the only thing I know is the 13 meters. I don't know the other two sides. So we're going to have to figure out one of the sides. Obviously, right now, the height I can't figure out. So the question is, can I figure out the diagonal along the base here? Okay, so let me redraw that to make that a little bit easier to visualize. So that's what this looks like. And so the question is, can we figure out the third side of that triangle? The answer is yes, because we have a right triangle and we know 2 out of the 3 sides. So we can use our Pythagorean theorem. We know the 5 and we know the 8. So 5 squared is 25. 8 squared is 64. And if I add those together, is 89. So that would be the square root of 89. Square root of 89. Square root of 81 is 9, so that's more than 9. So I know that's my longest side. And then I could take that into my other triangle here. This is square root of 89. This is 13. Square root of 89 squared is 89. 13 squared is 169. And if you subtract, that's 80. Square root of 80, it's almost 9. And that's what we're being asked, is to the nearest whole number. So almost 9, that would match up with answer choice B.